Good morning. My name is Ricardo Gonzalez and I am going to explain Newton's first and second law by using Tracker and modeling what was captured in Tracker using Python. Before explaining what the purpose and meaning of Newton's laws are, I would like to show you my Tracker video first. Now, as you can see, I used a peanut butter jar as my system because I noticed that it moved smoothly. Also, I had the opportunity to see that it didn't move sideways like a soccer ball would do, so I can assure you that it maintained itself on the x-axis. Notice also that the distance between the little red diamonds remained constant throughout the motion of the peanut butter jar. Now I will start the video again so that you can see the little red diamonds. You see, they are almost always in the same distance. This characteristic tells us that the movement was almost constant throughout the time interval. Now, keeping in mind what we saw in the Tracker video, we can take a look at Newton's laws. Newton's first law explains that an object remains in motion until influenced by another force. Here, in planet Earth, objects in motion are constantly influenced by other forces, such as gravitational force, drag force, friction, etc. But if we were in a vacuum, objects in motion would never stop moving because there are no drag forces in a vacuum. Newton's second law states that the change in velocity over a period of time, acceleration, is proportional to the force that acted upon it and inversely proportional to its mass. This law is critical for predicting motion of a moving system. The momentum principle. It is important to highlight that the momentum principle is equal to Newton's second law, because momentum is equal to mass times velocity. So if we substitute that in this upper equation, we get that force is equal to mass times acceleration. Now the overview of the experiment is the following. The system is the jar of peanut butter, as I explained previously, and the fundamental physics principles taking place are Newton's second law and Newton's first law. Newton's first law can be observed by observing the coding used in Python, and the surroundings is the floor, which causes friction. Now let's open the Vital file so that I can show you the coding that I used. Here we can see that the object's initial position was 0 meters and that the object's velocity was 0.06 meters per second. Now, since I said that the force net is equal to 0 because we are using constant motion, and in constant motion the force net is equal to 0, we can say that the velocity throughout the whole time interval is 0.06 meters per second, and the time that the object will be moving is of 1.166 seconds. Now if I run the code, we can see this. And using the Google spreadsheet, one can see that the model position, that the graph has a constant slope, it does not vary, while the experimental model has a varying slope. This is due mainly because the model graph depicts constant motion, and the experiment model has various external forces modifying its motion. These forces are friction, gravitation, and air drag, which slows down the velocity and eventually stops the object in motion. If I were to change the x-axis, if it were to go from right to left instead of from left to right, then both of these lines would be inverted, but the slopes would remain the same.